Okay. Well, happy Wednesday. Thanks for being here. Today, I wanted to cover working with strings in R. And so, we're accustomed to, all of your traditional stats classes generally deal with like numeric data, like all of regression, your ANOVA, all of that. That's all numeric data. But more and more, the data that we deal with has a lot of kind of text information, right? So pretty much all of the data sets, not all, but a lot of the data sets that you might find online include some text data, and we need to be able to kind of handle that text. It's certainly a lot of work and improvement and advances have been made here. And so you have these subfields of natural language processing, text mining, all of that kind of stuff. The large language models, which power, all this AI stuff, ChatGPT and Google Bard and all of these different things. They all have to be able to kind of parse text and parse language. Okay, we are not going to cover natural language processing or things like that, but we will cover, at least from a very basic, from the starting standpoints, like how do you even work with characters? How do you work with strings? And so we'll cover that, all right? And that will form as kind of a starting base point. And then certainly if you are interested in all of this stuff, here's a few resources that you can kind of look up, all right? Professor Almohawas now has a text mining class, I believe, and so there's that's something you can look at. Okay, more resources. So there is. We're going to look at regular expressions today and Friday. This slide deck covers is for both today and Friday. So you can start looking through it. Again, more resources, things on cheat sheets and different tools for testing out your regular expressions are here. Also just more stuff. So there's tons of resources out there to learn. These are ones that I've taken a look at and say are good, but there's probably even more out there. Okay. All right, let's just talk about characters in R to begin with. So basically, we use the words characters and strings. I use them kind of interchangeably, right? And they're one of the base types in R. So you can kind of store something like hello world in quotes into the name X. And then when you call and you ask what is X, you get back, vector of length 1 in quotes, hello world. Quote there, and this indicates to you this is a character string. When you ask type of on X, you get back character to say, hey, that, and this itself is a character string of length, or is a character vector of length 1, where its entry is the word character. Okay, we're accustomed to creating character strings. Probably most of you use double quotes, so you hit opening double quote. You type something in there, closing double quote. If you open and close with the double quote, you can put in things like the single quote, which is often used for apostrophes or whatnot. You can do that. You can also create character strings by opening and closing with a single quote. And if you open and close with a single quote, you can use double quotes inside the thing. And then when you print that out, you'll notice the default way R prints things out is it prints things out with double quote. And so therefore the double quote that was inside here gets what we call escaped, right? It puts a little backslash in front of it to indicate this double quote doesn't close off this double quote, right? So that's how we normally see it, right? When you see a double quote, you find the matching double quote to close it off. And here this backslash escapes it. That's what we call it. And it says, you know what, this This is a literal double quote, not meant to close this off. If you try to do something like this, include quotes inside your thing, but you don't escape them with a backslash, you'll run into an error, okay? You'll run into an error. Just like you have, integer 0, numeric 0, or numeric 5, or whatever it is there, you have this function, character. And what that will do is it will create a vector of a certain length. And the default value in when you create a character vector is the empty character. The empty character is this opening quote, close quote with nothing in between them. So this is a character string with nothing inside, okay? And so if I say character 5, it creates a vector of length 5, and we have 5 empty characters. The empty character, it's important to note, the empty character is not the same as character 0. Character 0 is a character vector with length 0. Basically, it has no entries in it, okay? Whereas if you had just one of these, that is character 1, okay? That is a character vector of length 1. That one item, though, is an empty character. One of the kind of most common functions that you'll use is the paste function, okay? The paste function takes our objects, turns them into character, and then concatenates them together, okay, into basically one longer string or multiple strings. The syntax is basically paste whatever objects you want to put in there. There's a separator argument. The default separator is the space, and then and the default is not to collapse it, meaning if you input a vector, multiple vectors, it will produce a vector of results. I'll show you some examples here. Okay, so the default is not to collapse, but you can change that so it does collapse. And then we have the kind of its twin function, paste 0, almost exactly the same as paste, except the default separator is the empty character rather than the space character. So here are just some simple examples. So you might see this shirt around. I ate some pie and it was delicious. And here pie, we get the floating point approximation to pi, 3.14159, so on and so forth. And notice it inserts a space. So the close quote ends at right after the E, but it puts a space in between the E and the 3.14. After the 9, it puts a space into, and it was delicious. Here I have Bears beats Battlestar Galactica. I'm going to say paste those together with the separator comma space, and it creates one character vector of length 1. The one entry is this character string where Bears beats and Battlestar Galactica are separated with a comma space. Okay. Here I have the character H. I have another vector, A, E, and I, and I say paste. And what this will do is it produces a vector of length 3, and the entries are H pasted with A, H pasted with E, H pasted with I. Okay, the separators being the empty character there. So we get HA, next entry HE, next entry HI. Here I have two vectors of length 3, A, B, C, and vector 1, 2, 3, and it pastes them element-wise. A goes with 1, B goes with 2, C goes with 3, and we get a vector of length 3. If I do something similar, but I specify a collapse argument, the collapse will then take the 3 different entries here. It'll be A1, A2, and A3, and it combines them into one entry. And so now I have a character vector of length 1. And the one thing is A1 comma space A2 comma space A3, which is distinct from a character vector of length 3, right? So I just want to make sure we understand the difference between this one up here and this one down here where I have a collapse argument. Okay. And again, it pastes things element-wise, but if you give it like something of length 2 and something of length 5, it's going to recycle them, I believe, and it won't throw a warning. Okay. Couple additional functions. We have print and cat, which we're familiar with, and I'll also show you format, which is used for kind of pretty printing. So with print, the default things is to kind of output the vector. You get the vector indicator, like opening, closing, square bracket 1 to indicate this is a vector. And it generally encloses the output with quotation marks. If for whatever reason you wanted to hide the quotation marks, you can do that. You can do print x and you specify quote equals false and it hides the quotation marks. Okay. There's also a function called no quote, and it's kind of like print for character strings, and it outputs this without quotation marks. There is a subtle difference between print quote equals false and no quote, and that is if you store the results of no quote somewhere, it creates a no quote class object, and so every time you print it in the future, it will be printed without quotes. Whereas print x quote equals false, x still is a character string, and when you print x in the future, it will have the quotation marks. Okay, here's the cat function. So remember, x is hello world in quotes, okay? And I can say cat x hello world and hello universe and separate them with comma space. And what this will do is it just outputs directly to the standard out, your computer screen, and it says hello world, hello universe. Notice there's no square bracket 1. The output is not a vector. The output is not something you can capture. So over here, I could take no quote x and store it into some other object, right? I could store it into object y, and I could recall that later. Over here, though, with cat x, I can't take this output and store it somewhere. Okay, I can't say store this into object y. So cat is different from print. I asked that question in your first homework assignment, and you guys kind of looked at it and try to figure out what the difference is, but this is one of the differences. Okay. One thing that you can do with cat, though, is you can have it output to a file rather than to the screen. So the default is when you cat, it just puts things out into the console onto your screen there. But you can say, hey, I want the output to go to a file. So you could just specify a file, and it will store the entries into hello.txt. There's another argument in cat. If you specify a file, you can also specify append. And what that will do is whatever cat outputs, it will add to the bottom of the file, and just that file will get longer and longer and grow. Versus if you don't specify append, it will just replace the contents of the file. So if you have other stuff in the file and you cat to that file name, it's just going to create a new file. Yeah, question?
So will it just create like this hello.txt, or does that need to be pre-existing?
It will create it.
Okay.
Yeah, so it will just write to hello.txt. If it exists, it will overwrite. If it doesn't exist, it will create it. And I think even if you say append and it doesn't exist, I think it will create it the first time and then append to it the next time. I think, but I'm not 100% sure on that. But I think that's what happens. You can try it out. Let me know if I'm wrong there. Okay, format will output our objects as characters, and it will just do some stuff that it says for pretty printing. It's not really that pretty. It's just like it's going to pad it so it fits a certain length, or round it down, or do these things. So here some of the arguments that you can specify and format, and certainly you can always read more in the help, but you can do specify the width to say, how many characters wide should the output be, trim, justify. This is kind of like I don't know if you've ever opened like just a plain text README file, and they've tried to do some formatting with like they use the equal signs to create like boxes and borders and things like that, and you kind of want everything a certain number of characters wide. That's what format could be used for, is to kind of set these things up. Okay. Also, when you print numbers, you can also specify a few things. Always keep in mind, the output of format is always going to be character types. Okay, it's always going to be strings. So you do some calculations with numbers, but you're going to convert them into character type with format. So for example, here I have do the calculations 1 divided by 1, 2, 3, 4, and 5. And here we say digits 2. And so this takes these outputs and it formats them into character strings with 2 significant digits, or 2 digits behind the decimal place. So I get 1.00, 0.50, 0.33, 0.25, 0.20. All of these are character type. Here I have scientific equals true. And so this is scientific notation. So 0.5 is 5 times 10 to the minus 1. 0.25 is 2.5 times 10 to the minus 1, so on and so forth. Here I have these words, hello world, hello universe, and I say format them so that everything has a width of 10 and left justify them. So it just adds spaces. So it adds 2 extra spaces after universe. It adds 5 extra spaces after world and hello. So all of these things have a length of 10. And there's a lot more you can do with format, but this is just kind of the intro there. All right, let me give you your first view quiz answer. So the letter D, D as in dog. D is your first view quiz answer, D. Okay, these are all basic functions that we have. These are all in base R. Nothing here is a regular expression yet or anything, but this is just things that you can do with characters, okay, and strings. So we have ncar, which is a number of characters. We have to lower and to upper, which make them lower and uppercase. We have translate characters, which is a little bit of a weird function. I've got some examples, and then you can extract and split strings. Okay, so here I've got this vector y with the words hello and then world and then hello and universe, and I say what are the number of characters in each of these entries. It says hello has 5 characters, world has 5 characters, etc. Universe has 8 characters. You can take vector y, make everything lowercase, and it takes all the entries in y and makes them lowercase, to upper makes everything uppercase. I don't think any surprises or shocks here. Character translation. This is the character translation thing. And basically, it's just kind of like replace this character with that character. So you can say replace capital H with a Y, and you get this. You could say replace ELIO with 3-1 exclamation 0. The E gets replaced with a 3. The L gets replaced with a 1. The I gets replaced with an exclamation mark. O gets replaced with a 0. And so hello world, hello universe becomes H3110, W0R1D, and so on and so forth. It's still somehow still legible. And so character translate, I can't think of very many practical use cases for this function, but it exists. It would work for, say, if you wanted to create like a little puzzle for children. I imagine, I don't know, like on the cereal box, on the back of the cereal box, you had like the secret message, and it said like, and you had little symbols, and each of those symbols stood for one of the letters in the alphabet, and you can do that. You could do something like that, right? You can say, all right, here, you take these 26 letters, and here are 26 other symbols that you could use, and you can do that. Okay. A limitation though is that you're limited to ASCII characters, basically. ASCII characters. So regular expressions, all of these things are very kind of Anglo-centric, US keyboard based, and so ASCII characters are pretty much everything you can type on a US keyboard. So that's going to be your 26 lowercase letters, 26 uppercase letters, the digits 0 through 9, and all of the symbols that you see on a US keyboard. So if you have a foreign keyboard, characters with accents and things like that, that's not part of ASCII. Okay. String manipulation stuff here. Okay, so substring, you could say, hey, so X is just the word hello world, or just the length 1 character vector. You didn't bring like water to class. And so 2 through 9 will extract out, starting at the second letter, ELLO to world, WOR. Here I have string split. String split, I say split on the space. And so hello world gets split into 2 things, hello and then world. We get a vector of length 2 here. Notice the output of string split is not an atomic vector, but it's a list, right? We see the double square bracket. Why am I getting a list for the output of string split? What do you think? So the thing is string split could take in a vector of, say, length 5, right? And so, your first entry could be hello space world. The second entry could be, apple space bear space cat space dog, okay? And the third entry could be something else. So when you call string split and say split on the strings, hello space world becomes hello, second entry world, okay? Apple bear cat dog, okay? After you do split string on the spaces, will become apple as the first entry, bear as the second entry, cat as the third, dog as the fourth. And so to kind of organize that, because now you're going to have vectors of different lengths, it organizes that into a list. So the first train car has hello and world. The second train car has the vector of length 4, apple, bear, cat, dog. The third train car would have whatever the contents of that third vector entry is after you split it, okay? So that's why the result of string split is a list, so you could have vectors of different lengths and things like that, depending on how many spaces were in the entry originally in X. Because X could be a vector of length greater than 1. Here's string split, where I split on the O. So hello world becomes hell, the O gets split on that. We get a space W. And then world gets split on the O, so we get, space W and then RLD. All right, let me introduce Stringer. Sorry, I'm like struggling over here. Okay, so Stringer is part of the tidyverse. And it basically tries to come up with some kind of consistent way for dealing with some of these entries. And I apologize for the formatting here. We have string _C for string concatenation, string length, which is similar to number of characters, string sub, similar to substring, string dupe will duplicate characters, string trim will trim white space, string pad, pads a string, string wrap, takes a string and wraps it into kind of paragraph, and then string trim will trim a string. And again, more resources to kind of read up on these different things. One thing that happens if you have null characters, length 0 character vectors, and you put that into paste, is it enters that. This, I'm a little bit thrown off by this, I think. I wonder if I messed something up here. I was expecting hello world, comma, hello universe, but here I'm getting a character 0 output, so that's throwing me off a little bit. But one thing about paste is that if you do have kind of this like a character 0 in there, it kind of inserts that in there. Okay. That works. Okay. It doesn't like it anymore. All right. So I guess it just maybe I have to collapse. That's what I was expecting, something like that, but a little bit different. Okay. This one, I guess it just removes them or something. Okay. Yeah, question.
For the first paste command, are they being removed or are they being replaced with just an empty character?
They're being replaced with empty characters here in this one. And then I think for here, it doesn't, I think I got to fix this. I think this thing is wrong here. They don't get removed. They get the output ends up being character 0. So I got to. I think they've updated the functionality here. String length does work for factors, and so we get outputs here. So if you have like a factor here, n characters will generally just fail on that, or string length does work for factors. All right, let me start introducing regular expressions. Let me give you your second view quiz answer. The letter B. B as in bear is our second view quiz answer. All right, regular expressions is basically a tool that we have for doing pattern matching. Okay, and this is really handy if we wanted to do any kind of data validation or any kind of text parsing or things like that. Okay, you can think of regular expressions as almost like a formal language where I have defined set of symbols, defined set of rules, defined set of kind of way to specify the patterns that you want. Okay, when you first learn regular expressions, it can feel overwhelming because there's a whole bunch of symbols. There's a whole bunch of different concepts and things to keep in mind. But if you use it enough, you will become fluent and you will become very proficient in them. I kind of compare this to like driving. The first time you drove a car, I don't know what this is doing here. First time you drove a car is probably overwhelming with all the different kind of controls. You have your turn signal and your wipers and obviously the steering wheel and brake and gas, but it seems like there were a whole bunch of things you had to kind of keep in mind and think about. But with practice, you just got better, and you might be at a point where when you're driving, your brain starts drifting off and thinking about other things because all of these things have become automatic. And so similarly, I think regular expressions is one of those things. In the beginning, it feels like a lot, but then if you use them a lot, you'll become very fluent. Okay. This is just a list of a whole bunch of stuff you can do with regular expressions. I won't even bother reading through it. Okay. These are some of the functions from string R that handles regular expressions. Now, R has its own kind of base R implementation of regular expressions. There's grep, and that will do. But I think the string R functions are handier and nicer to work with. So that's what I'm going to teach. The time and energy you spend learning regular expressions, I force you to do it a little bit in this homework. But I think it is time well spent because you will use them. I mean, well, I don't know what you're going to do in the future, but they translate. They're universal. So if you switch over to Python, you'll still use regular expressions. In C, pretty much any other language, all kinds of web-based stuff, I'll use regular expressions, and they're all kind of universal. So there's a one weird quirk about the backslash in R, but other than that, the regular expressions are pretty universal. So these are the functions. We've got string detect, string locate, string extract, string match, and string split. String detect, they're all in the form of put in a string and then search for a pattern. String detect will either return a true or a false. All right, so this is very handy to pair with, say, in dplyr filter, because filter is used to select your rows. Okay, filter your rows based on a true or false logical condition. So you can say, do you detect this pattern? If you do, keep that row. If you don't, filter it out. String locate will give you the position of the first match for that pattern. It will say in this string, this is where I find the first match. You have string extract. It will say, hey, here's the pattern, and I'm going to extract it out. String match is similar to extract, except, and I will show you later, is that in patterns you can specify what's called a capture group. So within a pattern, you might say, hey, I'm looking for this pattern, but really within that pattern, there's only one piece of information that I'm interested in. You specify a capture group, and string match will extract that capture group. And then string split will split strings and things like that. All of these allow you to put in vectors, and it will return either vectors or matrices or something, some form there. These also all have an underscore all variant, which will return all of the matches or whatever of the pattern. So the default here is they all find the first match as it reads left to right. So regular expressions read left to right, and the behavior as they're listed here finds like the first match. Underscore all will find all of the matches. And so the output of string detect, string match all, or string locate all, or something will generally be lists, just kind of like string split and things like that. I'll show you some examples of how this works. Okay. So the most basic type of regular expression is the literal character match. This is the same as using like the find function on, say, a Word document or a web page. You've probably done this like as you're writing an essay or something, and you realize, you know what, I want to change all instances of this word with another word, with a different word, right? So you can do find, and you are searching for a literal match. So you can say, find all instances of, the numbers 2024, or find all instance of the pattern, someone's name. Okay, that's a literal character match, and we will match that. Okay, so here we are going to search this string. I love stats. I space LOVE space STATS. All right, and then again, the input for the string could be a really long string, right? And it could also be a vector of strings. And here we're going to say locate this pattern, the literal pattern STAT. And so it says, I found it. It starts at character 8. And indeed, you can count 1, 2, 3, 4, 5, 6, 7, 8. S is the 8th character. 9, 10, 11. This T is the 11th character. And so that is the end. We get back a matrix with one row with 2 columns, the start and the end. Okay. Here, if the string that I'm searching is capital STAT, and I say search for the pattern lowercase STAT, it says it doesn't find it, so we get NaNA. All right, here is a slightly longer string. It says I love statistics, so I am a stats major. This is what you guys tell your friends, right? So we have string underscore locate. We're going to search for STAT. It's going to find the first entry here, and it says 8 and 11 for the stat and statistics. If I do string locate underscore all, what I get back, I'm going to get back a list of length 1, and the entry in that list is a matrix with 2 rows because it found stat here for I love statistics, and it also found STAT in this part that says so I'm a stats major. And it says that started at character 30 and 33. Right? Because again, the input for string locate all could be a vector of multiple strings, and it's going to find locate will find the first entry. So if the input here was a vector of length 5, it would find it would return a matrix with 5 rows, each row corresponding to where it found the first match. String, if you did the input was a vector of length 5 and you did string locate all, it would return a list of length 5, and each entry in the list would be a matrix with however many matches it found in that particular value there. Okay. So that is literal pattern matching. Very simple, very basic. The true power of regular expressions, though, come from these meta characters. Anything that is not a literal character is technically a meta character. The meta characters really give regular expressions their power, and they include basically the braces, the curly braces, the square braces, the curved braces, we might call those parentheses. Also, these anchors, the caret and the $sign, the quantifiers, the star, the plus, and the question mark. Also with our wildcard character, the operator or, and then the backslash to escape. So the dot or period is our wildcard character. This is going to match any character including spaces, symbols, letters, numbers, any character other than a new line character. So here I've got, as an entry, I've got a vector, not, note, not, and nut, and we're going to say, do you detect the pattern n.t? Do you detect the pattern? It's going to return true or false for each of these entries. So n.t matches not, n.t matches not in note, n.t matches not in not, and n.t matches nut in nut. So we get true, 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 true here. Here, my pattern is going to be no dot. So if I run it against here, we're going to get a match on not. We got no wild, no wild. So we get a match here for this. We don't get a match here because I have an nu, right? nut. So I get a no match. So I get true, 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 false. Okay. Here I have 5.00, 5100, 5-00, 5 space 00. What will 5.00 as the pattern? What will this match here? It's going to match all of them. It's going to get true, 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 true. Okay. If you want to match literal meta characters, so let's say you wanted to search for the actual opening square bracket, you can do that. You just have to escape it in your pattern. So when you say the pattern that I'm searching for, you can't put in just opening square bracket because it's going to think it's got the meta character meaning. So here you can say I want to search for the literal opening square bracket, and you escape it with a backslash. Now, because of R and R, the backslash itself is a meta character, you have to do a double backslash. This is kind of unique to R. Most other languages, you just use one backslash to escape a meta character, but in R you have to do a double backslash to do that, okay? If you don't escape the character with a backslash or double backslash, you get an error. But here it says, yeah, I found the literal opening square bracket inside the thing, okay? So coming back to this thing with the 5s and the 5.0, 05100, 5.00 is gonna match everything. If you wanted to match only this exact literal expression of 5 literal dot 00, you would use 5 double backslash dot 00, and that will match the literal 5.00 and not the other ones, okay? Okay, so far so good? Okay, we can also specify character sets. Character sets are defined by square brackets. You put characters inside that the set of square brackets, and it will match any of the characters in the square bracket. Now, the character set matches only one character. So here, I'm going to specify the character set, square bracket A-E-I-O-U, and this will match one lowercase vowel. So here I've got P-A-N, pan, pen, pin, P0N, P.N, P-A-U-N, P-W-N-3D, and happiness. And I'm going to ask, where do we have a match with P, character set A-E-I-O-U, N? So we're going to get a match on pan, P-A-N. We get a match on pen, get a match on pin, true, true, true. No match on P0N, no match on P.N. No match on P-A-U-N, because even though A and U are both in here, this character set matches only one character. We only match one character here, so that's not a match. P-W-N, no match. We do match the P-I-N within happiness, okay? So we do get a match there. So that comes back true. So that's a character set. If you wanted to define a character set with, say, all the capital letters in the English alphabet, you can do A through Z here, okay? That's kind of tedious, so we can use dashes to define ranges, okay? So you can do A-Z, okay? Or you can specify any other range, and again, it's just alphabetical order, so you can say A through Q, or A through F, or whatever you want, okay? You can do the lowercase letters, you can do the uppercase letters, you can do all 52 ASCII letters by doing A through Z, lowercase, and capital A through Z, okay? And you can also do digits in this way as well. So you'd probably do 0 through 9, or you could specify a range, 0 through 5, 0 through 7, 2 through 6, whatever you want, okay? And if you don't want them in, like, if you want certain numbers but not all, then you just have to type them out. You say, okay, I want 2, 3, 7, and 9, or whatever, if those are the characters that you want, okay? Otherwise, you specify a range, and you specify a range. Okay, so let's say I've got 1, 2, 3, ABC, ABC, smiley face, AB, 1, 2, A, you know, whatever this is, okay? What's a pattern we can write to say, I want to match 3 adjacent digits? 3 adjacent digits. Yeah, so we could write square bracket 0 through 9, square bracket 0 through 9, square bracket 0 through 9. So we could say I want 3 digits, 0 through 9, 0 through 9, 0 through 9. I'll show you a shortcut later, but for now, using just the tools that I've shown you, you could say I want 3 adjacent digits by doing square bracket 0 through 9. This will get your first one, square bracket 0 through 9 for your second adjacent digit, 0 through 9 for your third one, okay? And so we would get a match on 1, 2, 3. No matches on any of these, right? 1, 2A is not a match here. We will match the 890. It reads left to right, so the 890 will match, and we get a true there, okay? Similarly, if you want lowercase letters, 3 adjacent ones, you can do A through Z like that. You can also create negative character sets. Negative character sets basically say match any character except the ones in this negative character set. You specify a negative character set using the caret. Okay, so what, Shift 6 on your keyboard? So if you write this, square bracket caret, A-E-I-O-U, this means any character other than lowercase a, e, I, o, or u, okay? So here we could say, do not match the capital letters A through Z. And so we're going to get a match on everything other than the capital A here. Okay, so I'm going to get a true on the 1, true on the lowercase a, false on the capital A, and true for the other 3 symbols. Okay. The idea of creating a negative character set with the caret only works if the caret is in the beginning. Okay, if you put the caret somewhere else, okay, then this becomes just the literal caret character. So this is A through Z. So do match A through Z, or do match the literal caret character. So here, when I say detect this, we're going to get no match. We're going to get false, false, true on the capital A, false on the ampersand, false on the dash, true on the caret character. Okay. How would I specify anything except the caret? Yeah, so we would do caret, / caret. Technically, you could also just do caret, caret, because once you're inside a character set, the internal characters are already automatically escaped. But yes, you can do caret, / caret to say anything other than the caret. And so we will get matches on everything except for the literal caret there. Okay. If you put a meta character inside a character set, generally it is automatically escaped. So here I have AE, the literal dot, IOU, and so we will get matches on pan, pen, pin, not on P0n, but we will get a match on P.n, and we get that. Okay. All right. Okay. This slide, and we'll wrap it up here. These are little shortcuts for defining, I think, some very common character sets. Okay. So you'll notice there's a little bit of a pattern in that the lowercase of that letter is match that thing, and the capital is do not match that thing. So \d, \little d is match any digit, D for digit, okay? So this is \d is the same thing as the character set 0 through 9. So it'll match any digit, 0 through 9. \D is the same thing as caret, 0 through 9, anything other than a digit, okay? You have \W. \W is what we call a word character. This will match the letters, the digits, and the underscore. So you can think of this as like what is allowed for creating a username. Like when you sign up for an account somewhere, what can you put in your username? A lot of sites use just word characters to validate a username. So you'll have letters, numbers, and underscores, okay? And then you can do \D. This is anything that is not a word character. So it's just the caret in front of there to negate everything else. You have \S. This is for white space characters. White space characters include breaking and non-breaking spaces, as well as tabs, new lines, and things like that. Do you guys know the difference between a breaking space and a non-breaking space? Okay, so let me, hello, okay, so all right, my name is Miles Chen. I live in Los Angeles, California. Okay, so normally this is, let me see, how do I? So all of these are spaces, and so if I make things bigger, word, as I'm showing the hidden symbols here, as I make the text bigger, word will wrap the words, and so when it hits Los and Angeles, it's going to split there, okay? Now, you can have what's called a non-breaking space. All right, and so instead of a regular space, I'm going to hit, is it Alt space? No. How do I insert a non-breaking space here? Okay, so this is a non-breaking space. Okay, if I hide the symbols, it looks the same. It looks the same. The difference here is that when a word reaches the end of the line, it will treat this as if this is a character, right? It would never split Angelus between like the A, the N, and the G or something like that, right? The entire word goes over. So it's going to treat this as if this was one word without a space, and it's not actually going to split Los Angeles here. So when I grow this text here, so notice as soon as it can't fit, Los Angeles goes down there. It's not going to split the the two words Los and Angeles. Okay. So that's what a non-breaking space is. It's almost as if it were treated like this. Okay. Right. So if you had something like this where there was no space, you'd say, okay, I can see how this doesn't work. But then as soon as I put in a space, it goes over there. But if you do Control-Shift space, you get what looks like a space, but Word treats it differently. So that's a non-breaking space character. Still counts as white space, but that's what we have there. Okay. Well, your last view quiz answer is the letter A. A as an apple. A as an apple is your last view quiz answer. Okay, we'll wrap it up here. We'll pick up here on Friday. Look at more regular expressions. See you then.